Hi everyone, welcome back to another video. We are talking about function notation and how to evaluate functions today. So first let's talk about what function notation is. Now so far we've been used to writing our linear functions, or really any function, as y equals and then something on the right side. So we know now that y is our output and x is our input. If we want to write this in function notation, all we have to do is replace y with f of x, and we'll talk about what that means in just a moment. So I'm going to write f of x equals, and then I'm just rewriting the function, 2x minus 8. So from here to here, all I changed was the y. They mean the exact same thing. This is just something that represents y. And when we read it as f of x. So that's what I'm saying when I say f of x. Okay, so there's a couple important parts to our function. This part right here is our output. This is output. And right here is our input, right? So whatever we input or substitute for x, we're going to have an output, or this piece right here. So when we want to evaluate a function, we are going to substitute that value that we're given in for x. So let's try that out with a few example problems. The first one, we have f of x equals x plus 7, and we're going to evaluate it twice with different values. The first one is f of 5. So what this means is I want to evaluate this function right here when my x value is 5. So notice that what has changed here. This says f of x, so this just tells me this is my function. This tells me my function when x equals 5. Notice how the x is no longer there, the 5 is now there. So it just tells you to replace any x now with 5. This is just a really short way in math to say evaluate this function when x equals 5. But of course we don't want to write that out, so we have a shorter way, function notation. So if I want to evaluate this when x equals 5, I'm going to rewrite it, but I'm going to leave a blank everywhere there's an x. So see, I have a blank, and now instead of x, I'm going to write 5, right? We're replacing every x with 5. And now I'm just going to solve this. So f of 5 equals, and I'm just going to add these. 5 plus 7, that's going to give me 12. And we're done here. So careful, when you write your answer, we're not doing something to both sides of the equation. We don't do any operations with this. This is just our instructions, right? So we leave our instructions there. F of 5, or the function when x is 5, is 12. So your answer is 12. This is how you write your final answer. Let's try that again. Same function, but now we're going to evaluate it when x is negative 3. So again, I'm going to rewrite the function, but where there was x, now I'm going to input negative 3. So the function when x is negative 3, I'm going to rewrite that, is, remember our equal sign just says is, and then I'm going to add these together. 7 plus negative 3, that's like 7 minus 3, and that's going to give me 4. So this is my answer. The function when x is negative 3 is 4. That's how I would read that. Or f of negative 3 is 4. Okay, let's try it again with a new function. This time we have g of x. That's still function notation. This still just means y. I just changed the letter there, and I want to show you guys that it means the same thing. So we're evaluating this function when x is 5. So I'm rewriting everything, but where the x was, I'm going to put 5. Don't forget your order of operations. PEMDAS. Make sure that you do everything in order. So I'm going to do multiplication first, then subtraction. So 3 times 5 is 15. Now I'm going to subtract this. So if I do 15 minus 8, that's going to give me 7. So g of 5 equals 7. I'm going to kind of box that since I'm getting a little close to my next problem. Okay, and then another one that we're going to try is when the x value is 0. So I'm going to rewrite the function, but now x is 0. Okay, so doing our multiplication first, 3 times 0 is 0. And 0 minus 8, well, that's just negative 8. So my function when x is 0 is negative 8. let's think about this in other words. If I were to graph this, wherever my x is 0, that means my output is -8, right? So if I input 0, out comes -8. This point right here would be 0, -8. Just another way to think about it. All right, one more function and then we're going to try this on a graph. We've got x squared plus 2 now. So again, rewrite your function, but instead of x, now it's -1. Don't forget your order of operations. We're going to do exponents first, then add. So -1 times -1 is +1. Don't forget the plus 2. And then when we add that, that gives me 3. So when I input -1, out comes 3. All right, let's do same function, different number. So again, I'm going to rewrite it. But now my x value is 4. So using my order of operations, 4 squared is 16. Then we add 2. So my final output is 18. So h of 4 equals 18. It's really good practice to say these correctly if you've never seen this before. So go ahead and practice saying h of 4 equals 18. All right, last ones we're going to do are on a graph. So like I said, your inputs are where these x values are, and we're going to find what the y value is, or the output. So if I want f of -4, well, I don't have the function written, but I have it on a graph. So I'm going to find where x equals -4. Let's find where that is. Right here. Now my graph isn't hitting -4 on the axis, but if I see up here, this point right here, and let's see, that was my pink one, so I'm going to highlight that in pink. At x equals -4, I have a point right here. And our job is to find what is the y value. So let's see, I went -4 up 2. So this point is -4, +2. See how the x value is -4? And we found the y value. So I can write that f of -4 equals 2. This in the parentheses is the x value. What I get out, or the output, is the y value. Let's try it again with 0. So I want to find f of 0. Well, x equals 0 right here at the origin. Oh, and the graph also hits it there. So we have a point right here at 0, 0. That means when my input is 0, so is my output. So f of 0 equals 0. All right, let's try another one, f of 2. So I'm going to look and find where x is 2. That's right here. And so I have a point down here at 2, and it looks like my y value is -2. So f of 2 equals -2. Okay, and last one, f of 5. That one's in my gray, so I'll just do that with black. So f of 5, I'm going to go out 5 on the x-axis. Looks like right down here I have a point, and that point is 5, -1. So my y value, or my output, is -1 when x is 5. All right, guys, those are all the examples I have, so you can get started on your homework or whatever you have to practice. Thanks so much for watching, guys.